density radius r, density sigma, and there's a density of liquid. Okay, rho, let it be rho L, and quotient of viscosity eta. Release from rest here. Now, what are the forces that are acting? First, the weight will act. Gravity also you have to take it. This is what? Viscous liquid. Castor oil, oni, different things. Fine. Okay, now, what actually happens? The first weight will act. So it will get into the liquid. It will get into, so here, let me keep one thing here. You know, no. What are the various forces that will be acting on it? Mg, buoyant force, and the viscous drag also, no? And initially what happened, the weight is able to overcome the viscous drag and buoyancy. So therefore it will be in fact accelerating, and it will also possess the velocity. Now, because of acceleration, the speed will keep on increase. If speed increases, the viscous drag also will increase. And at one instant, both these two, the buoyancy and viscous drag, will balance the weight. And what will happen to this particular sphere? It is going to move with a constant speed. So here, so what is the condition? Mg, I'll put, yeah. So in between, if you check it, no, again, yeah, we are having all the total. At t equals 0, it was released here. So let's say it's a simple mathematics, laws of motion, we know it. So if you come and check it, it will have velocity v1, it will have acceleration a1, here viscous drag, and buoyant force. These are the forces that will be acting. So till here, what is the type of motion it will describe? It will describe an decreasing acceleration and increasing speed. Then afterwards, it is going to move with an uniform speed, or better say constant. And it will acquire one velocity called as V terminal. I'll show it like this. Don't think that no forces are acting. All the forces are acting, but what will happen to them? The net force will be 0, and it will continue with its uniform velocity motion, constant speed. This Vt is called as terminal speed. This is the overall motion. I'll show complete. All of you are able to see this? I think this will be sufficient. It will continue. It will move constantly with it will move uniformly with a constant speed. So why do this happens here? I'm bothered about this particular thing. I'm not bothered here. The reason for that, first weight will act. It will accelerate. Due to acceleration, speed will increase. If speed increases, see, buoyant force and mg, they're fixed here. But viscous drag depends on what? Viscous drag depends on what? The speed of the sphere. So as the velocity, because of acceleration, as the speed keeps on increases, viscous drag will increase. So tell me what will happen to the net force? Net force will be decreasing. Therefore, I'm saying decreasing acceleration. Fine. Go back to the kinematics. If acceleration decreases, speed can increase. So increasing speed. Finally, at one instant, The viscous drag and buoyant force, what they do, they will balance the weight, and net force will be zero, and it will move with a constant speed. How long? As long as liquid is present. As long as, I'm saying as long as. I'm interested in this terminal velocity. I'm interested in this terminal velocity. So let's write this Vt, that one means finally when it attains the thing. So finally what happens when ball attains terminal velocity or moves with a constant speed. So what should be the net force? Fvt plus Fb should be equal to mg. What is Fvt? Eta, we know. Here the viscous drag according to Stokes law, 6 pi eta rv. What is small r? Small r is the diameter, the r is the radius, v is the terminal velocity. Yes, sir. Where is the vessel? No, infinite liquid. So what is this? This is as good as like a what is the boundary here? That's why I'm not showing boundary. I'm not saying that it's a cylinder in a cylindrical vessel. I put it. So look at this particular thing. There's no any specific boundary. So when this formula is applicable? Only when this boundary is infinite. Even ocean also is a finite, no? For that, what happened? The Stokes he has proposed a law. The viscous drag acting on the spherical ball is given by 6 by eta. Don't say, sir, at what distance from this? There's a infinite liquid. So what is the, uh, I should call this as infinite boundary. For that, the Stokes has proposed this formula. We know buoyant force. What is the density of liquid? Rho L 4 by 3 pi r cube. What is the mass? Sigma 4 by 3 pi. Just accept it at your level. You can't go for, sir, I'll derive everything. For that you should know very good mathematics, no? If they're required, we would have taught it. Don't bother all that things. No. Okay, there's a rho L. I'm interested in this Vt, no? Expression for this Vt. So 6 pi eta r Vt is equal to sigma minus rho L. Here one G is there. No, here, so shall we do one thing? 2 will take outside. So this will become 2 by 9. 1 pi r will also get eliminated. Look at the formula, 2 by 9. So this is expression for the terminal velocity. What will happen to this? It will continue to move, finish all. There's no doubt on this one. As long as the liquid is present, it's going to continue to move with the terminal velocity. So the terminal velocity, it is directly proportional to square of the radius. R is the radius of the sphere. Now, what is the Stokes law? This is the Stokes law. Fine, this is just a formula, very important formula. Plenty of numericals are there based on this. I'm saying the plenty. Okay, let's get expression for how the graph for this will be. Let's get the mathematical. Let's get expression for acceleration. So I'll proceed with the mathematics. It's a very simple, the stroke light sword, but you get plenty of numericals on this one. So let's get some mathematical part. So initially, the same thing, will release it, it will accelerate, and afterwards, it will move with a constant speed. Okay, these are the some things what we know. mg, velocity, viscous drag, buoyant force. They're the viscous liquid. Afterwards, it will move with a constant speed. So, same discussion. This is what? Acceleration. Fine. Okay, let's get expression for acceleration. So what is MA? MA is equal to mg minus fv into fb, this one. So this A is equal to g minus fv by m. Further, g minus 6 pi eta rv buoyant force should be, let me write it. So this should be sigma 4 by 3 pi r cube rho 4 by 3 pi r cube g by sigma 4 by 3 pi r cube. A equal to g. This will be 9 eta capital R, 9 eta v by sigma 2 sigma r square minus. So this will be rho g by sigma. Okay, I'll do one thing. This is g. Let me call this is alpha, this is beta, and the acceleration, let me write dv by dt. So again, similarly, I'll release from rest and attention of this with the condition. Okay, now minus 1 by beta log of, so this will be log of alpha minus beta by alpha equal to minus beta t. I'll send on log on that side, so will become e to power of minus beta t. So this will become 1 minus, or v is equal to alpha by beta. What is alpha? Alpha will be g. Let's write the final equation. What is beta? Beta is this everything. 9 eta by 2 sigma r square minus 9 eta t by 2 sigma r square. So don't get scared. Just the equation is of this form. G, this eta will cancel out. So this will be sigma minus rho by 2g r square by 9 eta. Anybody, how this graph will be? Can you remember some graphical problems we did? Very beginning, no? So the mass background. How the how the graph will be exponentially increasing one. It will not increase linearly. The speed of the, it will not acquire terminal velocity by linearly. It is released from rest here. Here, release from rest at t equals 0. This is at any time t. So now how the graph will be. So if I plot the graph will be exponentially increasing graph will be of like this. So this is the expression for V and this is the terminal velocity. Are able to understand this graph? I'll bring complete page. You can see now. It's just kinematics, huh? You know. So what is the terminal velocity? Alpha by B. Now we know it. So if you want to write it, what is VT? VT should be alpha by B. After a long time, sir, I'll take the ratio of alpha by B and check it. Yes, you'll end up with the terminal velocity only. You can see this one. So what is VT? VT should be alpha by B. So when do it will attain? Practically what happened for something. So after almost here, the change will be negligible. So this is the graph what they proposed here. So what they ask you, what is the type of question? So you know, like it's a pure kinematics. Huh? Find the acceleration of the sphere. There's a sphere. Find the acceleration of sphere when the speed of the sphere is off of the terminal velocity. Tell me what you're going to do. I think this is the best expression you have. You should not forget it. Or sorry, the best expression. Tell me like when the speed of the bob is, when the speed of the sphere is off of the terminal velocity. So what is the terminal velocity? You know it, off of it. That value you have to substitute. Then you'll ask you acceleration. I think you have to be very, very alert here, the knowing things in exam, because the content is very simple. There are only two formulas. F equal to eta A dV by dr, F equal to 6 pi E eta RV. Find this one. So this will be this one. So I'll ask you further, what is the distance covered by it? So what should you write? ds by dt. Again, you integrate it. They may not also, they may ask you to plot acceleration versus graph V, how the graph should be. This is a constant negative slope. So acceleration is going to decrease, no? Is it a uniform retarding motion or variable accelerated motion? Anybody? What type of motion? Before attaining terminal velocity, what is it? Variable accelerated motion. Getting the idea now? These are some graphical questions they'll ask you, or say like a V as a function of time, then acceleration as a function of speed. So any graph for this VT? VT is called as terminal velocity. Acceleration as a function of speed. So shall we go for one more graph? No, initially it will be how much? Equal to G, no? And finally what will happen? V terminal. It will be zero, no? Finally acceleration should become zero. So it is equal to G, this one. So this is slope. This is what acceleration as a function of velocity. or the speed of the bob. So then this is the terminal velocity. Once the velocity of the bob equal to terminal velocity, acceleration becomes 0. So any graphical questions here can be asked. Okay, these are some Stokes law we have. So like any other object we have to derive. It's not that easy. Suppose like sir, I'll move a cone. Again, we have to bring a formula. And it is moving inside the liquid. Everything is a liquid. Please keep that in mind when we discuss terminal velocity. No, so that's, and what is the boundary? There is no boundary. Sir, what is the vessel you are using? It's a vessel of infinite shape, infinite boundary. That is what. Then only that Stokes law is applicable. That's why so strictly it is applicable. This one. Now, what is that viscous drag? By the liquid on the sphere, no? By the sphere on the liquid. Yes, it will be there. By the sphere on the liquid also will be there. Similarly, buoyant force, what is the buoyant force? Buoyant force is what, like by the liquid on the sphere, by the sphere on the liquid also. Now, what are the type of questions shall I ask you? When the sphere attains terminal velocity, find the force exerted by the sphere on the liquid. Tell me what you are going to write. You're going to say the viscous drag, and the buoyant force is what? The force exerted by the sphere on the liquid. Am I right? Cross way of asking questions. So what students will do, so like how to calculate on the liquid? No, Newton's third law, action, reaction, equal and opposite. What force the liquid will exert on the ball, the same force the ball will exert on the liquid. So what is FV and FB? Force exerted by the liquid on the ball. By the ball on the liquid, the same thing. So here somewhere I'll write it in corner, this data. Note. Objective questions, these are some troublesome. Force exerted by the liquid on the ball, or I think we took sphere. Let me use sphere. Force exerted by liquid on the sphere or by sphere on the liquid is sum of viscous drag and buoyant force. Fine. So like this, we have to calculate the same thing. In exams, what they ask, find the force exerted by the